audience is an early career, at least identifies as an early career researcher, which is pretty good because, let's see, it's a big relief, else I would have to change the talk, and that would be quite difficult. So welcome all, and thank you for attending this early morning plenary. I think it's towards the end of the conference, and I hope you have been having a good time. I know I certainly did when I attended this conference last year, which is what Katrina just mentioned. So my name is Trisha Gopalakrishna. I am yet to get my doctorate from the University of Oxford. Like I mentioned, I just finished about 2 weeks ago, and I still haven't received any paperwork. Yeah, today I'm going to try my best to provide an early career researcher's perspective about the complexities of forest restoration, which is the area of research that I'm interested in, using a case study of my home country, which is India. And here's how the next 35 to 40 minutes of the hour is going to go by. I will start with setting the background of forest restoration in India, which will hopefully make the rest of the talk more comprehensible, especially for those who don't have a background in these two topics. And then I will look at three specific complexities that I explored as part of my doctorate, and then conclude with an outlook. And throughout the talk, I will do a couple of polls, which is very similar to the one that you just did, if you identify or do not identify as an early career researcher. And I hope you participate. It's the same thing. You use your phone to scan the QR code, or you log into slido.com with that same hashtag. I'll put it up. And yeah, we'll just get a sense of what people feel about being an early career researcher and what it takes to be one. And another thing that I wanted to say is a lot of the studies that I've cited in this talk are by early career researchers. And yeah, so please do look them up. They're pretty interesting, and do cite them because it's fabulous work that all of us are doing, and everybody needs to know more about them. Okay, so forest restoration is been touted to be a silver bullet for a variety of global environmental challenges we face, specifically climate change. There is mounting evidence that forest restoration, when compared to many other strategies such as protection and improved management of different ecosystems, has the highest potential to mitigate climate change. Also, forest restoration has a variety of other benefits, including supporting biodiversity, including supporting local livelihoods and human well-being, which is very context specific, and that's where the complexities bit comes in. Also, there is increased momentum of forest restoration strategies being included in multiple policy fora, such as the Climate COP, which is the UNFCCC COP, and then we have the CBD, the biodiversity discussions, where restoration is one of the main tenets. And it has garnered a lot of attention from many countries that have set very ambitious pledges and targets as part of campaigns such as the Bonn Challenge and the New York Declaration on Forests. We are currently in the UN Decade of Ecosystem Restoration. And it's also been considered a win-win strategy to meet multiple sustainable development goals. But the true question is, can it live up to all these really high expectations? And I'm going to try and say and make the case, at least, that it's very complex, and maybe in some instances it does not live up to these high expectations. Okay, so a little bit about India. India is interesting because it has ambitious pledges to the Paris Agreement, with expansion of forest cover being a key part of its nationally determined contribution, which is the pledge each country has made to participate in the Paris Agreement. It has even more ambitious restoration targets as part of its Bonn Challenge. It has the highest pledge when compared to all other South Asian countries. It is a big biodiversity hotspot. We have a lot of diversity, endemism, and in different parts of India regarding various taxa and things like that. And also it is one of the fastest growing economies in the world, and it has ambitious sustainable development goals post-COVID. And that's pretty key to keep in mind, considering India is also the most populated country in the world, and it has all of this amazing biodiversity and potential, but it's also trying to be an economic giant. And considering all of this, there's still very little information about whether forest restoration is a viable strategy for India to pursue to meet all of these very big goals that it has pledged to do. So I'm going to actually ask again to use your phones and take part in this poll. Let's see if it comes up. There we go. How important is research impact in motivating you to do your work? So it can vary from it's my main motivating factor, or I never think about it, to I write about it in grant applications, or I consider it a little bit, or oh, I really am interested in it, and it makes me want to do my research with a lot more vigor and a lot more interest when I get out of bed because of it. I'm going to give it another few more seconds. Okay, I'm going to call it at that. So yeah, that's pretty interesting. Yeah, many people think it's one of the main motivating factors. That's pretty interesting. Okay, so a little bit about me, and this is where I guess the context would help. I basically started my entire research and what I wanted to do with my life with motivation being one of the main factors, and for me to do what I do. So I would be this part. I would do my research only if it created impact. But like most of you, I think I've slowly slid down, and I do consider it and I do think about it, but it's becoming harder and harder for me to think about and include it when thinking about research ideas and thinking about how I'm going to plan my career, which is quite interesting, at least to me, because that's a big difference from where I was and where I'm going. So coming back to what this means. So a little bit of context, as Katrina said, before I started my doctorate, I used to work on a research topic called natural climate solutions. So what are natural climate solutions? These are strategies that we, and by we, I mean governments, environmental nonprofits, finance sector, intergovernmental bodies, can implement to mitigate climate change. So for example, within the forest biome, the strategies could be avoided conversion of forests or management of disturbances such as fire in forests, which is mentioned on the y-axis by biome on the plot on the slide. And on the x-axis is the resulting climate change mitigation potential shown as the petagrams of CO2 equivalent gas removal per year. And interestingly, if you look, reforestation, which is another word for forest restoration, it's the conversion of land that is not forest currently back to forests. It provides the highest mitigation potential, which is shown by the longest bar on the slide. However, you notice that the confidence intervals or the uncertainty on that bar is also pretty large. And we found a similar pattern of the high mitigation potential of reforestation in the first countrywide analyses of this natural climate solution. So all these strategies in the United States. And that was quite interesting, but we wanted to ask then, what is the real reforestation opportunity in the lower 48 states? And is it feasible? And what does it look like? How much does it cost? And are there any other benefits apart from climate change mitigation? And what we ultimately devised is that we developed an entire menu of options for different stakeholders, right from practitioners who are on the ground actually doing the work to policy analysts who represent the US government. And we try to propose different options of what reforestation could look like. So if you look at the first option, what would reforestation mean in protected areas of the US? Another option is that if there's land area in the US that is not very optimal for agricultural lands, and a farmer is not making the most profit using that land for agriculture, what if we were to convert that area into a forest, and the carbon credits that the farmer could sell would provide a revenue stream for the farmer? So that's another option. And the other co-benefits we looked at is, for example, if you were to reforest to do some sort of connectivity to allow mammal movement, how would that look like? And for example, let's take the state of Tennessee, which is shown on the map, and all the areas that are in pink are areas where you could convert the land to forests, and you would get some sort of climate change mitigation benefit, because as trees grow, you know that they extract carbon from the atmosphere. And at the same time, there would be connectivity for movement of mammals to keep track with their climatic niches as the earth warms. And this was interesting because we validated the entire study with many scientists and conservation managers across about 20 US states, which is shown by the black dot on the map. And it was pretty eye-opening, at least to me, as I was a 25-year-old doing this kind of work. And sure, we published the work actually pretty recently, and it hardly has any references, which I know is an important metric of success when doing scientific research. But the policy impact has been quite immense. So, for example, there's been uptake by many other organizations in the US when it comes to this particular study. Also, the US Department of Agriculture and the President's Office, which are government agencies, has used the evidence that we generated to set their environmental budgets for different subsidies and different grant schemes to do reforestation in the US. However, the biggest impact was that the final report, which is called Path to Paris, which the Biden administration used to re-enter the Paris agreement, included estimates from this study. And this research was pretty impactful for me because I felt very fulfilled with the kind of work I was doing. And that's the research experience that I had before I started my doctorate in 2019. And as I started to design my doctorate research, I was actually very excited to think about it in terms of what the impact would be. And it turned out that it's quite difficult. I went from being part of a science team in a relatively influential and international environment nonprofit to being just a student, setting out on a pretty lonely 3.5 year journey of completing my studies. And I constantly kept in mind how could I create a doctorate thesis that could still address some of the important issues that we think about today. So yeah, I decided to look at forest restoration, but in the context of India, which brings me to complexity one. So I've already mentioned this. There are so many studies in the last 4-5 years that have estimated where there is area to do forest restoration. And if that area were to be restored to forest, how much mitigation potential would be possible. And these are a couple of examples of the studies that have come out. And such global studies are pretty valuable because they highlight broad scale patterns driven by global scale processes, but they're actually limited in their ability to account for locally specific information in regions or countries which can easily deviate from the global estimate. And additionally, these global estimates can overestimate the actual potential because they either include areas that are inappropriate for forest restoration, such as grasslands and savannas, or they have a limited exclusion of agricultural and pasture lands, which might endanger food security. So the first question I asked is, where is there forest restoration opportunity in India, and what is the resulting climate change mitigation potential? And this turned out to be a pretty complex question to ask, because that's where the context and the specificity came in. So overall, what did I find? I found that the total opportunity to restore forests in India is actually very, very less when compared to many of the India-specific estimates from global studies. So a couple of which I've shown on the slide. The many global studies are in pink, which provides the area available in India to restore forests back to, and my study is the little small bar in black. And this is very, very surprising to me. And as a first year DPhil student in 2019, 2020, I was very amazed, and I actually was very worried that my entire analysis was wrong. And one of the main reasons for this is that India has extensive and intensive existing land uses, which means that there's very little unused land which can actually be restored to forests. And the main policy implication is that the targets and pledges that India has made in this sector might actually not be very feasible, and they might need to be reassessed. So what do I mean by that? And I'll show you the results in more detail in the next slide, but if you look at the cumulative climate change mitigation potential of forest restoration and agroforestry in the area that I will speak about in a bit, it's only about 21% of India's pledge to the Paris Agreement, which is actually not quite that much. And it does emphasize that we need a diverse portfolio of carbon removal strategies, and that forest restoration might actually not be the most beneficial strategy to bank on, especially when it comes to India. So let's look at the results a little more. There's actually only 1.5 million hectares of opportunity of land area available in India for forest restoration. That's only 0.5% of India's land area. And it results in a cumulative mitigation potential of 61.3 teragram C, which is not that much. And one of the novelties of this study is that we were able to break down this 1.5 million hectares and 61.3 teragram C for each Indian state, which actually had not been done in 2019, 2020 when I was starting my doctorate. There was only one study, which was that US study that I showed you that looked at sub-jurisdiction analyses. And also we showed that there's a lot of variation in the potential for different Indian states. So the central Indian states, which is shown in the darker shades of orange, have a really high mitigation potential, and they would be very interesting to do any sort of reforestation activities when compared to, say, the Western Indian states, which is the lighter orange shades, where there's actually not that much potential. And this is quite different when compared to agroforestry, which is the plot on the right. And we estimated that there's about 14.7 million hectares of land available for agroforestry, which is about 4.5% of India's land area. It's not quite a lot, but it is quite a lot more than 0.5% for forest restoration. And that's where the nuances came in and the complexity came in, is that for India, it actually might be more appropriate for the government to invest and plan their agroforestry activities, their grants, their schemes, their support for farmers to put trees on their land to meet its many ambitious climate goals when compared to actually doing restoring forests. And however, when doing this analysis, it made me aware of the diversity of existing ecosystems and land covers across India. So I wanted to truly understand what are the implications of restoring forests and lands on biomes that are not forests. And this goes to the next part of, or the next complexity that I will explore. It's very difficult to actually do forest restoration in land area where you actually cannot distinguish whether the land naturally hosts forests or it naturally hosts an open ecosystem like a grassland or a savanna or a woodland. So for example, the image on the left is an area called the Nilgiris, which is the Western Ghats in southern India. It's very close to where I'm from. And you can see that naturally there are lots of grassland and forest mosaics. And this was a picture taken in the early 90s. And this is a picture taken pretty recently in 2018. And it shows that a lot of it has now been converted to plantations, which is quite interesting because many, at least open ecosystem or grassland savanna ecologists would say that this is not the natural state of these mountains. And we know that afforestation, which is conversion of land area to forests where forests are naturally not able to exist, is a big threat to grassy biomes. There's been a lot of literature that has come out that it endangers and many of these ecosystems, and it actually has adverse effects on the global carbon cycle, because we know open ecosystems actually store a lot more carbon, and it has adverse effects on biodiversity that is hosted by grassy biomes and many ecosystem processes and functions which are very specific to grasslands, savannas, and woodlands. And it's a bit of a difficult topic to tackle because forest restoration has just been the golden child. It's the policy focus when you look at restoration and the idea of restoration that many people have. It's planting trees. That's like the big thing. But this is actually a very problematic area in research in India, especially because there have been multiple various like lines of evidence which are shown on the slide that actually hints that India's dominant ecosystem is actually an open ecosystem, which is savanna, woodlands, and grasslands. So for example, there have been museum records dating back to the 1780s that show that there is evidence of endemic savanna understory plants, which is shown by the plot on the left. I mean, yeah, my left. I guess it's your right. It's the first plot. And there's also a lot of vegetation modeling, which has shown that open ecosystem shown in pink and blue is actually the dominant ecosystem in India. And there are a lot of natural history accounts you can see that which showed historically that there were lots of open grasslands, which are actually now forests and close canopy forests. And this is quite interesting because the open ecosystem, so grasslands, savannas, and woodlands in India are wide ranging. Some of the examples are shown on the slide. And it's very difficult to actually differentiate some of the savannas specifically from forests, because a lot of Indian savannas have like physiognomies that are very similar to close canopy forests. So it supports the idea that there might have been forests here at some point in time. Also, there is this colonial legacy of management of land in India for timber revenue, which has perpetuated this idea that a lot of savannas where there are no trees, or there are trees that cannot be harvested for timber, are actually wastelands. And this legacy has persisted today because a lot of land use land cover maps that India has classify savanna lands as degraded forests. And this is very important because many government agencies in India actually use these land use land cover maps. And there has been much evidence that a lot of the savanna lands that in India have been allotted for afforestation and for solar energy farms so that India can meet its climate pledges, like see the Bond Challenge, for example. So the next complexity that I'm going to talk about is actually what are the drivers of tree cover across India's forest and savanna biomes, and what makes it, what's the difference in the tree cover. So the main findings is that India is very complicated when it comes to understanding tree cover in savannas and its forests. And what we found is that when looking at tree cover across India's savannas and forests across a water deficit gradient, we delineated 4 zones of tree cover. So you have the uncolored, like the blank zone, and the green zone, where you have really, really low tree cover and you have kind of high tree cover. And this is dominated, or it is determined mostly by the climatic potential. It's how much water is in the system through precipitation and in the soil. But then there are these 2 interesting zones in between, where first there's the yellow zone, where you have tree cover, which is approximately about 25 to 35%, which is shown by the black dots. But you also have evidence of understory savanna endemic plants, which is shown by the orange dots. So you have both tree cover and savanna understory plants, but the tree cover is not above, it doesn't go beyond like 40%. So there is some sort of climatic determinant for it. But then there's this lavender or purple zone where the tree cover goes up to like 80%, but then you also have savanna plants, which is shown by the orange dots. So there's like an overlap. It's a mixed forest savanna zone. And one of the main things that is interesting is that in this yellow zone, which is like a core savanna zone, you see a lot of savanna understory plants clustering. And you see also tree cover only reaching about 40%. If you were to think about it in terms of forest restoration, one could argue that this core savanna zone should not be afforested because it's a completely different, it's a specific, unique biome on its own, and it should not be targeted for afforestation. But the lavender or the purple color zone is quite interesting because we don't know. There's tree cover that could go up to about 75%, but there's also savanna. So it's what actually determines this tree cover is the next question. So what we ultimately ended up doing is that we determined something called the climatically determined maximum potential of tree cover, which is shown on the map on the left, which means that all the areas which are in light shades of green means that the tree cover is it has a less climatic maximum potential, and the darker shades of gray means that there's high climatic maximum potential. And then we determined something called a deficit, which is shown on the right, which shows that areas that are in red, the current tree cover has not reached its maximum climatic potential. So there's a difference. And it could be, but there's something stopping current tree cover from reaching its maximum potential. But areas in blue is where the current tree cover has already reached its maximum potential. So there's nothing stopping a tree cover from reaching that potential. And we try to then determine what are the factors that help current tree, would allow or not allow current tree cover to reach the maximum potential. And what did we look at? We looked at a variety of factors which are very commonly understood and looked at in the savanna literature. And the main findings that we found is that topography is actually a pretty important factor when considering how tree and grass compete, such that you have a forest and a savanna, which is shown by the first two plots. And it shows that there would be a lot of, the trees would outcompete grasses in areas that have a lot of solar radiation. So on warm southwesterly facing regions, which is indicated by a topographic metric called heat load index, you would see trees outcompeting grasses. And this is a similar pattern which is shown in another topography index, which showed that in the bottom of valleys, there is a lot more tree cover than actual grasses. But as you go to the mid slopes and if you go to flat areas, then there's different competition. Grasses then compete, and there's a lot more grasses than in the upper slopes and ridges. Another interesting and very intuitive finding is that of the impact of anthropogenic disturbances, which we used population density as a proxy. So as you increase, there's more anthropogenic disturbance in the landscape, tree cover actually decreases, which would give a chance for grasses to outcompete, and there could be a savanna. And the other important thing was that of herbivory pressure, is that if you have sheep and cattle actually grazing, so they're going to eat up a lot of the grasses, and hence it would allow tree cover to, tree cover to actually reach its maximum potential, as the grasses would be controlled. So the main actually finding is that, yeah, there are certain areas where afforestation should not be done. So it's that yellow area in the previous slide that I showed you. And that's pretty important when thinking about forest restoration strategies. And the next finding is this area where you have both forests and savannas, which is this purple lavender area. It's a lot more nuanced. There's a lot more factors that need to be considered, such as topography and anthropogenic disturbance and herbivory like sheep and cattle. And it's not as easy as tree planting. It can't be that simplistic, which is at least how forest restoration is thought about in many different parts of the world, including India. And for the final complexity, I'm going to slightly switch gears, and I'm going to talk about if you know the mitigation potential of forest restoration, you know where to do it, you know that there might be implications for savannas. So you know all of this, and when you start doing forest restoration, are there any additional benefits that you would accrue? And this is quite important because, as I mentioned, especially the way restoration has been thought about, it's very carbon centric, but then there has been a lot of what do you say, calls from this, especially from the scientific community, that is asking for this carbon centric idea to be expanded to include other benefits. And this mirrors the global policy forum or ideas that we are seeing. There are a lot of different commitments and pledges, like I've already mentioned, which ranges from climate to livelihoods. So there is a need to understand how different benefits can be optimized, or we can secure different benefits, and not just carbon and climate change mitigation, but many other benefits when doing forest restoration. And also another important thing to keep in mind is that when there are different benefits that are accrued from forest restoration, there are very big trade-offs between them. So the classic example is, if you were to think of a restoration of timber plantations, which are monoculture plantations. Yeah, they're fast growing species and they would lock up a lot of carbon, but I don't think they necessarily are a good thing for biodiversity. That's like a classic example of how do you understand trade-offs when it comes to restoration. So again, there's a lot of literature on this already. So one of the seminal studies from 2019 showed areas that are in shades of red or orange, where there is a lot of benefits, more than carbon, such as biodiversity and water services when doing forest restoration. And this was a very simplistic analysis, because it took geospatial information for many different benefits and stacked them on top of each other, and just found areas that where there's a lot more of the geospatial information, which is kind of biased because it just shows us where there's GIS information and where there isn't. And to improve upon this, there was another seminal study that came out in 2020, which actually used optimization. And optimization is the process by which you understand the costs of doing any sort of activity, in this case, forest restoration, and the true returns. It's an actual algorithm which works through spatially to understand where you could get the maximum returns from any sort of activity that you're getting, and considering the inputs that you're putting in. And yeah, this was actually a pretty cool study, which showed, which again, in shades of red are all the areas that is priority for restoration. And I like this paper because, yeah, it used optimization and not just stacking of GIS layers on top of each other. And the biodiversity metric here was species extinction rate. And it was done for all mammals and birds and reptiles and amphibians of the world. However, a big problem of this study is that it said that a lot of the responsibility for forest restoration actually falls on the tropics, which means that a lot of the liabilities on the tropics, which is actually quite unequal. It causes a lot of inequity issues, which was again brought about by many other scientists and researchers. And it's a very important topic to think about. We all think about equity and diversity and inclusion in our work. And this was a key example where a lot of the priority restoration area ended up being in the tropics, which means that the responsibility is on tropical countries, which actually is quite unequal. And there needs to be this sort of idea of how do you understand equity when it comes to doing restoration, and who is doing restoration and who is being benefited from it. So this led to the framing of this third and last complexity. And I look at it through the framework of nature's contribution to people. And this is a framework which goes a step beyond ecosystem services, because it actually assesses the relationship between nature and people. And it relies on the context and culture and different values that people have with nature, and that's the foundation. So it's not just an economic sort of lens which you think of when considering ecosystem services, is that there's a dollar sign on it, but this actually tries to include the context and the values of people and their relationships with nature. And so the main idea for this complexity is to try to understand the trade-offs between multiple nature's contributions to people, which I'll explain in a bit, and see if there's some sort of spatial pattern across India, and also to understand the equity issues. Who's actually going to gain or not gain from any of the nature's contributions to people? And I try to look at it using two different types of forest restoration strategies. So forest restoration strategies that are very carbon centric. So if you were to look at the bond challenge, or if you were to look at carbon markets, you would do restoration only keeping carbon in mind or climate in mind. But if you were to look at forest restoration strategies that are more like holistic, and they try to look at multiple ecosystem services or nature's contributions to people, that's a multi-objective strategy, because you're trying to look at a holistic sort of system. And the three nature's contributions to people that I looked at was, one, yes, climate change mitigation. I looked at the habitat that would be created for forest dependent mammals if the land area was to be restored to forests. And the last is the societal reliance. If a land area was to be converted to forests, how much of it could people in that area rely on to meet their basic needs of livelihoods, energy, and also housing, construction, material? Those were the main like societal reliance that I looked at. So what did I find? There are a lot of findings, but this is where the complexity comes in. So I'll try to be very brief. I'm going to only talk about the multi-objective strategy because that's the overall finding. Multi-objective strategy, I'm going to reiterate, is a forest restoration strategy that tries to optimize multiple nature's contributions to people, not just say carbon. And if you can just keep your eyes on the black line, that's the most important line. So in each of the plots is a nature's contribution to people. So the first one is climate change mitigation potential. It's on the y-axis. The second one is the habitat area target for mammals in India, forest dependent mammals only, by the way. And the last is the societal reliance. How many people would be able to get their fuel wood, would be able to get their housing construction, like wood material, and also would be able to get some sort of forest related livelihood. So those are the three subplots. And in each of them, if you see, the black line is always the second line. It's the second best solution, the black line. And that just goes to show that multi-objective strategies actually have the least trade-offs when it comes to providing all of these services. So that's how you understand it. And if you were to look at this spatially, this is how it would look like. Again, I will ask you to focus only on the last plot, which is the multi-objective forest restoration strategy. And if you look at it, there's a random pattern. There's no concentration of shades of blue or yellow, which is very obvious if you look at the top two plots, where there's a lot of blue in the southwest part of India, which is the Western Ghats, or the northeast of India, which is another like important hotspot for forests in India. So if you look at this last plot, there's a random pattern. And this is a good thing, at least according to me, because this means that there are multiple options for implementation of forest restoration schemes. And that provides a lot of flexibility for policymakers to choose sites. And it means that additional criteria like land tenure regimes, which is again a very complicated issue in India, and governance and other like important criteria, like is there a sufficient seed supply chain if you were to do some sort of a forest restoration. So you can add all these contexts and then accordingly make a decision of which site to choose. And the reasoning for this random pattern is the inclusion of people and societal reliance in the narrative, when compared to just focusing on, say, climate change mitigation or biodiversity, where there are clear hotspots. And it's interesting to know this because a big proportion of Indian people actually rely on forests for their daily needs. So, for example, there is evidence that about 60% of India's population do not have electricity for more than 4 hours in a day. So they actually rely on fuel wood for a lot of their energy needs, especially for cooking. And that goes to show that if you include uh, people and the people component in this sort of analyses, the results are very, very different if you were to just think about climate or just think about biodiversity. So that's another finding. And now talking about what's the equity, like who gets all of these benefits, who gets the benefits from the societal reliance, like who are these who benefit. If again, just keep your eyes on the gray black bar, because that's the multi-objective strategy. The total length of the bar is the number of people to whom there would be any sort of delivery of fuel wood or wood for construction of houses or a forest related livelihood. And the darker proportion of the bar are socioeconomically challenged proportion of people in India. And it's a particular sort of classification, as it's based on caste, because Hinduism is the dominant religion in India. And if you notice, the darker proportion of the bar is pretty high and pretty consistent in the multi-objective strategy. It's almost half of the total. So at least half of the total number of people who would benefit from restoration of forests for their livelihoods and housing material and energy belong to socioeconomically challenged backgrounds. And that's a pretty important idea or to think about and to understand who's actually getting the benefits, and are we actually having some sort of impact on different classes of society in any context. But I looked at only distributional equity, which is how are the benefits distributed to different classes of society. And there are many, many other equity aspects like context and recognition and procedural, which I didn't look at, and it's something worth looking at. And also another big thing is that it would be interesting to understand the benefits accrued by different genders in Indian society, because yeah, as all of you know, it varies, like women and men and trans, it completely, who benefits, just it depends. We don't know if it's equitable, we don't know if it is not equitable. And also it would be interesting to look at it in terms of different power dynamics. I just looked at socioeconomically challenged sections of society, but there are many different classifications based on wealth and things like that. And so this was just another a complexity that needs to be thought about when looking at forest restoration. So a quick summary of the three complexities that I've looked at. So starting from the bottom left, I think it would be, yeah, bottom left, is that there is very little area of opportunity available to do forest restoration, especially in India, when you account for existing land uses and land covers, and that agroforestry actually might be a more feasible option for the Indian government to pursue when it comes to meeting its ambitious climate goals. Another implication is that forest restoration can adversely affect India's lesser known savannas, and there are clear no-go areas where afforestation should not be done. And there are interesting factors like topography and human disturbance and herbivory, like grazing from cattle and sheep, that needs to be considered instead of like simplistic tree planting initiatives, which is how it's talked about. And lastly, you could design forest restoration strategies to meet multiple benefits, so not just carbon. It would provide the least trade-offs, and it could there would be multiple options for site selection, which is quite a good thing because it provides flexibility and it allows inclusion of other variables. And last, it would be equitable when considering the benefits that are delivered to different sections of Indian society. So I'd actually like to again go back to the poll. So if you can, again, bring your phones out, and this is the last poll, I promise, to just get an idea of what all of you are thinking about this topic, is how important it is for you to be supported by your early career researcher friends. So again, it varies. Do you just don't need any help and you just do your own thing? or you occasionally ask help from your friends and stuff like that, or you always are very collaborative. You do depend on a lot of your community, not just friends, but the larger early career researcher community to help you do your research, think about ideas, do your analyses and stuff like that. Yeah, I'm going to leave it up there for like half a second because I know we're almost at time. Okay, that's, oh, it's still moving. Okay, I'm going to stop at that. And yeah, that's pretty cool. Yeah, so I am pretty much on this I depend on my wolf pack kind of idea. Yeah, I depend on my peers quite a lot for motivation, for inspiration, because I think there are some fabulous ECRs out there doing like amazing work, and some of their research I've already cited in my presentation. And that brings me to the last part of my presentation, is that in order to bring together a lot of the ECR community, especially in restoration science, I had the very good opportunity with another colleague, Tina, to have a special session only for early career researchers at one of the annual meetings of the Association of Tropical Biology and Conservation, where we had 6 of us who were doctorate students who presented our work. And we got a lot of ideas because we did a similar polling sort of survey during our session. And we got a lot of ideas about what early career researchers think should be the next advances in tropical restoration science, and what are the challenges and opportunities. And all of this is online, by the way. You can look it up, and the video of all our presentations and the polling and everything is online. So this led to something called uh, like visions that we thought of that are important, and it's the voice of the early career community, researcher community, when looking at tropical restoration science. And more importantly, we provided some steps that early career researchers, especially doctorate students, can take when doing their research, because we all know being a doctorate student is pretty difficult. We have very little amount of time to do a lot of good research, and it's quite intense. So some steps that one could think of. And this led to a special feature in restoration ecology, where we invited only early career researchers to submit their work for peer review. And it was a great opportunity because, again, I heard about and read about a lot of fantastic work that is being done by my peers. An example of which is shown on the slide is what the LGBTQ plus community of restoration scientists who are early career researchers think about their challenges, and what obstacles do they face, and what are the recommendations that can be implemented by universities and departments to actually help them. So this was one such example of a paper that was peer reviewed. And yeah, so there are all these different complexities, like I've mentioned, in forest restoration, three of which I've spoken about today. But I think there's an additional question that we should all think about is, yeah, how can early career researchers tackle all these complexities and research questions while continuing to be motivated and being a part of a great research, or creating a great research community. So yeah, with that, I'm going to stop the presentation, and that's the end of my talk. Thank you. Oh, I also wanted to say thank you very much to the conference organizers, especially Katrina. Yeah, this was very difficult. I know it caused a lot of problems, but I do really appreciate this opportunity. And yeah, thanks for taking a chance on a doctorate student. And yeah, I applaud you because you're leading the way for voices to be heard in the science community.
Thank you very much. I hope that you heard the applause. It goes through the microphone only. So there was a big one. And I believe we can take some questions.
Hello, Trisha. Amazing work. I really loved it. So I have one question is like, amazing work, really good work, and very practical, I would say, when it comes to, I mean, I'm from India, so I know about what is going on there. Let's just say that. So I was wondering if you have any plan to somehow communicate your study to the policymakers, to the government, and how much do you think they would care? Because, you know.
Yeah, that's a good question. And this is something I've been grappling with being a PhD student. Like I said, before it was all done because I had a job at a cool like nonprofit that did all of the engagement with government agencies and things like that. And yeah, I actually don't know. So the first complexity that I mentioned, which gives the area available for forest restoration in each Indian state in India and the mitigation potential if that area was to be restored. Yeah, that got some traction. And because it got covered by like Munga Bay, India, and it got covered by Carbon Brief and things like that. And that was, I guess, one sort of engagement. And that's when thinking about research impact, we all know this, we all do science communication. So that's something I think all of us do. I think that's one of the ways I thought that I would do research impact, is that it was getting covered by many outlets, which are pretty important, at least in India. So that's one, I think, way in which I communicated my results. I don't really know if it ever reached any government agency, whether it reached the Forest Survey of India or whether it reached the Ministry of Forests and Environment. I don't really know. And yeah, I'd love to hear if anybody knows how to do this, because yeah, I don't really know how to do research impact properly. And sometimes I don't know what that means. So yeah, that's my short answer to you. I don't know if it's a okay answer, but yeah, that's basically what I've thought about. And yeah, the other two complexities, yeah, if you have any ideas of what I could do, please do like let me know, like email me. That I would be very grateful.
Hello, hi, great talk. Just one question. Are there, to your knowledge, any examples of this multi-objective forest restoration like being applied either in India or somewhere else?
Yeah, so this is the thing, that multi-objective forest restoration strategies, I think it's a kind of a new sort of novel sort of idea. Those two papers that I showed, which is Pedro Brancaleone's paper and Bernardo Strasberg's paper with the global map with the red in it, which was published in 2019 and 2020. That's pretty recent, actually. Those are the two instances that I know of, which were global studies. And as all of you know, with global studies, they have their own assumptions and their own like data and stuff like that. So I would want to say that I have heard that there are other region-specific multi-objective sort of optimization studies that are being done, especially in Brazil, by the same Bernardo Strasberg team. So in like the Atlantic forest and stuff like that. And also last year at the Montpellier conference of this exact annual meeting, there is, I think he's still there. I kind of forgot his name, but he works at AMAP, who does this sort of optimization for restoration, I think in like New Caledonia. And I forgot his name, but he actually is a postdoc, I think, in AMAP, and or he was then, or he isn't now. But that's another example. I can look up his paper because it got published in our special feature, his paper, because he was like a postdoc. So that's another example. But yeah, I can't think of any other examples, say in India or any other like tropical countries. If anybody else knows, do let me know, because I'm very curious.
Okay, please, one last question.
Hello, Trisha. Congratulations on a very nice talk, and congratulations on your PhD also coming up. I'm slowly getting into the field of restoration ecology, so I still have a lot to learn. But my feeling is that a lot of the research is focusing on where to do restoration rather than how to nurture the process. So I see it almost like raising a child. It's like we're selecting where there's childcare options, but not factoring the costs and what it takes to raise life. So I was wondering if any of these global studies are considering the costs of restoration and maybe the case in India if there's some more like nuanced view on the topic. Thank you.
Yeah, that's a good question. So both questions. So the first answer is that yes, especially the last complexity, which is the multi-objective strategy, the Strasbourg paper, they do have financial aspect because they include opportunity cost. So the land area, if it was not converted to forest, what would be the cost? If it was still agriculture, what would be the revenue? So that's what opportunity costs are. And the implementation costs as a criteria in then understanding where to restore forests. So that's been done. And there's a lot of the national climate solution studies that I showed with the bars. That also includes a financial component. So there's a price per ton of carbon dioxide equivalent gas extraction. So there's a price at $20, at $100 and $50, I think. But again, it depends which those numbers are made up. Like if you look at the EU trading system, the what do you say, price for 1 ton of carbon is very different. It ranges from like 20 pounds to like 80 pounds because it depends on what type of forest you're restoring. So that's one example of including the price. And I mean, 2 examples. One is the opportunity and implementation cost, and 2 is the price per ton of carbon that's extracted. So that's all been done globally, and that's also been done in the US, where there's, in the US, it's actually very difficult to do it in the tropical biome, because at least I found it difficult in India because I couldn't figure out the data I don't know how to find like land value data. And I think that's one of the caveats or one of the drawbacks of that Strasbourg paper, is that the reason they found that the tropical biome is priority area is because land is cheap and labor is cheap in the tropical biome when compared to other biomes to do restoration. So the way the optimization algorithm worked is that they try to optimize for low cost, and it picked the tropical biome. So that's the reasoning behind it. So it's kind of difficult, and I couldn't figure out how to do that sort of analysis because the data, I don't know where the data is to, and there could be proxies. You could look at, if the land was agriculture, what would the revenue be if it was converted to different kind of crops and stuff like that. So yes, there has been research done in terms of opportunity and implementation costs and the price per ton and things like that, but it's the rest of it, like the nuance of it and the details, is actually very difficult, and I can't think of any research that has been done tackling that. But if anybody else in the audience has, then please do let everyone know. Let me know as well. I'm curious.
Okay, thank you very much. So thank you, Trisha, for joining us. Thanks for the talk, and everyone here, please enjoy your coffee break. Yeah, so now we have got 45 minutes. If you want to join your mentor, the donuts are here just in front, and otherwise